Welcome in. Our objective for this video is to use kinetic molecular theory to explain some properties of gases. We'll start by looking at what properties of gases that we are going to care about, measure, and calculate. There are four main ones. We can calculate the pressure of our gas. We can calculate the volume of our gas, the temperature of our gas, and the amount of our gas. The pressure of gases is due to the fact that we have our gas particles colliding with our surface constantly, providing some force applied across that surface area. The more collisions that we have happening, the more pressure that we are going to have exerted by that gas. We can have relatively low pressure or relatively high pressure based on how many collisions are occurring. This could be due to our concentration. This could also be due to the speed that our molecules are bouncing around. We've probably experienced some changes in pressure in our lives. This happens when our ears pop going up in an airplane or up over the mountains. What happens is at higher altitude, there's lower pressure, and our eardrum acts as this little barrier between the inside of our brain and the outside of our head. When you get up to those high altitudes, all of a sudden there's less pressure on the outside of your eardrum, until at some point the inside pressure causes that eardrum to pop and equalize that pressure. Like we said, we can measure and calculate pressure, so we need some units. The SI unit for pressure is the Pascal, although in chemistry we are much more often going to be using units of ATM. ATM is approximately the pressure exerted by the air around us, the atmosphere around us. And it's more convenient because, as it turns out, the Pascal is a pretty small unit. Other applications might call for pressure in units of torr or millimeters of mercury. This is based on how pressure used to be measured commonly with mercury barometers, measuring how high the air is able to push our mercury up a narrow glass tube. As it turns out, the atmosphere on a normal day can make this column of mercury about 760 millimeters tall. These days, we try not to use mercury as much in our everyday lives, but the unit persists as a way to measure pressures. These other properties we've seen before. Volume we like to measure in liters or milliliters or cubic centimeters. Temperature we can calculate in terms of Kelvin for our calculations. And the amount of gas is always going to be in moles for our gases from now on. Our way to explain how and why gases behave the way they do is called kinetic molecular theory. It's composed of these 5 postulates, these 5 points. The first one says a gas is always just a collection of particles moving in a straight line. Our gases are bouncing around, moving just in a straight line until they collide with their container or with another particle. Number 2, our gases are not interacting with each other. There are no intermolecular forces. When collisions happen, molecules don't attract or repel or stick to each other, they just bounce off. Imagine pool balls on a pool table. Number 3 says that there's mostly empty space in our gas samples. And finally, number 4, why this is called kinetic molecular theory. The kinetic energy of our particles is related to, proportional to, the temperature of our gas. Proportional here means the same trend. We can give it the symbol, the Greek letter alpha. This just means as one increases, the other also increases. In practice, this means at higher temperatures, our gas particles, on average, are bouncing around much, much faster. We can use our kinetic molecular theory to explain why things work the way they do. We know that gases are very compressible. Well, this is because of postulate number 3, the empty space that exists between our gas particles. If there's lots of empty space, we can change the volume and still have our gas existing happily bouncing around that container. We also know that gases assume the shape and volume of their container. This is because of postulate number 1 and 2. Our gases are just traveling in a straight line until they hit the side of the container. That means they are going to keep moving until they fill up the entire container. When they do bump into things, they don't stick to it or attract or repel. They just bounce right off, which leads to our intuition about why our gases take on that shape and volume. We also know that gases have very low densities. Again, this is because of that third postulate. There's lots of empty space. If you take one liquid can of soda and convert it into a gas at room temperature and pressure, you'd have to have 1,700 times the volume. There we go. We've introduced our kinetic molecular theory, and we can use this to explain some of our properties of our gases. Well, there we go. Thanks so much for tuning in. Hope you all have a great day, and I will catch you next time.